So this is Unit 6, Learning Objective 15. We are ordering compounds in order of increasing, boiling, or melting points. So the boiling and melting points are determined by how well the molecules stick together. So this has to do with the intermolecular forces, or the IMFs. So it is determined by the boiling point and melting point of a substance is determined by the strength and type of intermolecular forces present within the molecule. So if I have very strong intermolecular forces, I have a very high boiling and melting point. If I have very weak intermolecular forces, I have a very low boiling point or melting point. So there are 4 things that you need to look at in order to determine which substance will melt or boil before another substance. The first is the type of compound. So if you have an ionic compound, it is going to have a higher boiling point or melting point than a covalent compound. So ionic compounds have a higher boiling point and melting point than covalent compounds. Then the second thing that you want to look at is what type of covalent compound do you have? A polar compound has a higher boiling point or melting point than a nonpolar compound. The third thing that you need to look at is what type of intermolecular force do you have? So IMFs. So what type of intermolecular forces do you have? A hydrogen bond, so an H bond, is going to have a higher boiling point or melting point than a dipole-dipole or a London dispersion force. Okay, so London dispersion force is going to be the lowest, dipole-dipole higher, a little bit higher, and then hydrogen bonding is going to be even higher. So the fourth thing that we look at is the molar mass of the compound. So let's say we've got 2 compounds that have dipole-dipole and London dispersion force. Then we're going to look at the molar mass of the compounds. The higher the molar mass is, the stronger the London dispersion force is. So a higher molar mass has a higher boiling point or melting point. This is due to stronger London dispersion force. Okay, so then let's go back to learning objective 14 and the compounds that were there were the compounds that were there in learning objective 14. So if we look at these 5 compounds here, we can see that we have all polar or nonpolar. So this guy here is nonpolar. He's the only nonpolar, which I would say is going to be the first thing that boils. So he would be number 1, okay, because he's nonpolar. He's the only nonpolar compound that I have, so he would be number 1. He's going to be the first one to melt or boil, depending on like what we're looking at, okay? And again, we are ordering these in order of increasing melting point. So he's going to melt first. And then we're going to look at, okay, I have polar, polar, polar. The rest of these compounds, the other 4 compounds here, are polar compounds. Now, I'm going to look for the ones that have the least number of intermolecular force. So a smaller intermolecular force, smaller number of intermolecular forces indicates a smaller melting point or a boiling point. So I have formaldehyde. So I have formaldehyde here, and I have fluoromethane here. Now, both of these have dipole-dipole and London dispersion forces, dipole-dipole London dispersion. So the thing that I need to look at is which of these is going to have the stronger London dispersion force, because again, the molar mass is tied to the London dispersion force. So I need to calculate my molar mass of fluoromethane and formaldehyde. So for formaldehyde, I'm looking at 16 grams of oxygen plus 12 for carbon plus 2 for each of the hydrogens. And this is just a rough estimate, right? So you don't have to be perfect with this. So this is 0. So 30 grams would be this guy's molar mass, or about 30 grams. And then I'm going to do the same thing over here. So I've got 12 plus 19 for fluorine plus 3. So 9, 10, 11, 12, 13, 14. So this is 34 grams. So this guy has the higher melting point. So this guy has a higher melting point than this guy. So this would be 2. And then this guy would be 3. Okay. And then the next thing that you look at, again, so like these two, looking at hydrogen peroxide and methanol, I'm looking at, okay, I've got hydrogen bonding, dipole-dipole, London dispersion, hydrogen bonding, dipole-dipole, London dispersion. First thing that I want to look at is how many hydrogen bonding spots do I have? Because the more hydrogen bonding spots I have, the higher the melting point. So hydrogen peroxide has 2 places to hydrogen bond, whereas methanol has 1 place to hydrogen bond. So I would say that hydrogen peroxide would have a higher melting point than methanol. So then this guy would be 4, and this guy would be 5. So order, ethane has a lower melting point than formaldehyde, which is a lower melting point than fluoromethane, which is a lower melting point than methanol, and then which is a lower melting point than hydrogen peroxide. So let's say that you are very tempted to cheat on this. Google is your friend, right? Well, let's see if you got this right. Okay, so I looked up the boiling point, the melting point for ethane. Oh, it's negative 297. Okay, that's pretty low. And then I look up formaldehyde. Negative 2.2. Pretty cold. All right, that's okay. Fluoromethane. Oh, negative 109 degrees Fahrenheit. And then I look up methanol. Oh, negative 144 degrees Fahrenheit. And then I can look up hydrogen peroxide finally. 31.2 degrees Fahrenheit. Now, if you had looked these up, you would see that you would flip methanol and formaldehyde. That's a problem because I'm going to expect you to do it based solely on intermolecular forces present within the molecules, which is how we did it. So if you look these up, it's very highly possible that you actually mess it up. So high encouragement not to mess this up, like not to go and look them up, because most likely you're not going to get it right. So again, this is learning objective 15, order compounds in order of increasing boiling points and melting points. This is based solely on the intermolecular forces present within the molecule. So first thing that you look at, do you have an ionic compound versus a covalent compound? Ionic compound is going to be higher boiling point and higher melting point. Then polar covalent is going to have a higher boiling point, melting point than a non-polar covalent compound. Then you look at the intermolecular forces. How many intermolecular forces do you have within the molecule? And then you look at molar mass. Higher molar mass usually has a stronger London dispersion force, which creates a stronger intermolecular force.